All right, now we're going to design this C-clamp. It's going to clamp onto a table. We're going to have a bolt going through here, and then there'll be a hook going over the top of this with weight attached. In another video, we've already designed the M11 bolt and a nut. Now what we're going to do is modify this nut so that it can act as a foot, so that when the bolt goes through here, the foot is here and it clamps it onto the table. So the bottom of the table here, the top of the table will be on the bottom of the foot. So let me show you what I'm talking about here. Let's go over here to one of these views, and we can even take a different slice at it here so that we can revolve a foot onto its surface. So let's find one of these good views for that. Something like that should do it. Click OK. What we're going to do is make a foot. So we're just going to draw something simple down here at the bottom. So let's stay on that same plane right there. Right click on that, new sketch, and we'll just find something that's in the middle, like, yeah, I guess right about here. We'll go out here a bit. You can come in at an angle, or you can go up like this to make the foot. Maybe something like that. Then going in over to here and then back down. Let's see if that's enough to give us a very rough idea about what we're trying to achieve here. For some reason, I guess I didn't close that surface. I thought I did. When that happens, you just go back and edit the sketch. Oh, it says I'm still editing the sketch anyway. So let's see if we can add another line. Maybe it didn't see this one to right there, perhaps. I thought I had everything in there. Let's try that again. So there's the shape right there. We don't really want to extrude, excuse me, we want to revolve, but we want to revolve it around this selected axis right here. We'll see how that looks once we get a good view of it. Let's delete the section view, look at the home view, maybe orbit around like this. You can see this is going to be a good foot. It's going to give us a good surface area um, on top of the table, and then the bolt goes into that right there. So go ahead and save that as a foot, and you can use any dimensions you want to, any kind of shape. We're just using some freedom in our design, so we will just save this one as an M11 foot. So that's going to be at the bottom of the bolt for our C-clamp. So we can close that one out. We know this is going to be our bolt going to the top. We can print that one out too. But let's go ahead and design this one right here. So we're going to need a couple of dimensions. And so let's just start back up here where we had began working on before. This is edit the sketch right here. You see what we did was we said that this is going to bite into the table 1.5 inches. And the gap right here, we calculated this based on our table width and our foot size to be 1.85. So let's go ahead and draw that shape. And so we'll just design it from scratch to make sure you understand how to do all of these things. Now let's see, it's going to be in inches. So let's go to English like this. These are inches like that. Create. And let's just start making a sketch. Usually from this side is good for what we're trying to achieve. And what we can do is just draw out that shape like this, and then start making some measurements. We said that this distance right here needs to be 1.5. And then this distance right here needs to be 1.85. And of course, those are, too many digits, but we'll ignore that for right now. 1.5, 1.85. All right, now in order to make this, I guess, fully defined, you can see there's this kind of floating out there. What we could do is just take the midpoint of that one right there, like this, and then put it coincident with the origin. I just wanted you to see that it was a C shape that we had there. Then what we're going to do is make some curvature to this. And so what we decided in class was that a 1/4 inch on these fillets is going to be good. Now we're just going to do fillets at the sketch level. So let's see, where is that at? There it is. And so you go 0.25. I think it was set at an eighth, but we're going to put it at a quarter there and there. And we want to make sure that we still have an opening of that and that. Yeah. So that just means that what we're going to need to be doing is for this offset, we need to go this direction. Now, how much thickness do we want on this one? You see 1/4 of an inch. And then in order to extrude that shape, we need to have it be closed. So let's close off this part with a line and a line right here. Hopefully it's now fully defined. And we can begin our extrude. And let's do a bidirectional extrude so that we can put uh, it makes it easier to put the bolt at the top of this if we do a bidirectional extrude. Looking at that extrusion, you can see that the amount of it is probably going to be an inch, and it's bidirectional. So let's make sure we use that one like so. Let's save this one as C-clamp. And I think I'm on like version 4 or something like that. Just making various changes to it. Looks like everything, I'm not sure that it was fully defined at the middle. So let's go back and edit the sketch. I did see some purple in there. So maybe what I need to do is to make sure that um, this and this are collinear. And that was it. So then just roll those changes forward. And let's go ahead and put some kind of threaded piece up here. And so what you'll see is that we added a little bit of material there so that there would be enough threads to for this here. So if we go to let's see, I think it's going to be this one here. What is this? This the hole probably? Let's see what this is. So you edit the feature and you can see that it's actually a hole, which we don't really need that one just yet. Come back. Let's just edit the sketch right here. And you can see that this distance right here is the 10 millimeter. I think we have to change that though. Let me check and see. And this right here is, I wonder why there's an equation associated with that. Um, yeah, I'm not really sure why. Oh, they said add a 1/4 inch to it. Okay, so whoever designed this one just added a 1/4 inch to that one right there. What we can do is just do it by feel if you want to. One of the things that we talked about in our homework when we're making this bolt in this video, let me see if I can get over to that for you, is the size of the hole. So you saw in the measurement that the hole size for the nut here, it was 10 millimeters. I found that it's better to make it 9.6 millimeters to make it a little bit tighter. And that makes a better fit with these threads. So we're going to use that instead. So let's go back over to here and we're going to be drawing a circle. We will, I guess, maybe just set up a space for us there and here and here. X marks the spot, and we can come in there and make those construction lines. This is where we want that 9.6 millimeter hole. And then we want some kind of structure around the outside, which is really our choice. Now, what the person chose was that made the last design is they said the distance between those two right there was well, the diameter. So I guess they did 0.125 to make it just a little bit bigger. All right, so what we need to do is, give it a little structure, so that there's more teeth in there for the bolt to bite into. So we're going to extrude this outer ring right here, and we don't really need to go very high. When we just really go probably just an eighth of an inch, which is 0.125. All right, that looks good. And then we'll do a plus sign right here and make sure that we punch out the rest of this right here all the way through to the next level, which is going to be to right there. So now we have a place to put our threads in there. Okay, so we'll come back and do the threads in a minute. Let's just go ahead and put our hanger on there next. So be sure to save periodically. And we'll see that the way the hanger is achieved is with a rod down here. Let's see which one of these is the rod. Looks like it's this one right here. So we will edit the sketch for this one right here, and you see that it's simply just a 1/4 inch rod. It's located 3/4 of an inch down and 1/2 an inch in. Those are kind of three easy numbers to remember. So let's see if we can pull that off. We're going to go over here to the side view. This one right here, right click, new sketch. And we'll just put that 1/4 inch circle right down here. We want it to be directly below this one so that the weight, see if I can get this to move down. There we go. So that the weight is right below the point of contact of the foot, or the center of the foot, rather. So let's see if we can do that. If we measure from here to there, that should line up to be 0.75 and be directly below that. It may not be that way. So we're going to go up here and measure here to there. Oh, we see that it's 625 there instead. Probably because of the way that we did that. So maybe not have it right there. Let's make that distance be 0.625. So you do have some design freedom. This is kind of an unscripted lab. You can decide some design changes on the fly, as long as you get the main ideas going here. Oh yeah, this one's the one's 0.75. We said that one was a half, but I think it was because of the way that we centered it up on that platform that became somewhat different. We will do an extrude of that tube, that circle. It needs to be bidirectional. It needs to be 1 inch. So it's directly below this. So we put our hanger over the top of this. Now the hanger needs to be supported, or that rod needs to be supported. And in class, we chose to do a sketch on this surface and put a slot from the structure to the rod. The slot is down here, and we'll go center to center, right. Oh, okay. I didn't really see that for some reason. Okay, let's see if we can draw a line from center here. That seems to be easier to do. Why did it not lock in here? That's odd. So when that happens, I usually just try to get it to find the center. Worked a minute ago. So let's maybe project some geometry here. Let's go over to the sketch, project the geometry. Oh, I think I know why it's doing that. Okay, we'll do that and that just so we can see it a little bit better. Let's go back to the slot. And that worked much better. And we're going to have it go all the way up here to the top. That way it's just an easy lock-in. Now, as far as why it's not fully defined, I'm not really sure. So we will just go show all degrees of freedom. And apparently it can move to the left and to the right. I don't really see how. Okay, I see why now. It didn't really lock into the top. So what we could do is say, let's make this top part right here, that one, and we're good. Going to the side now, we can extrude inward to give it a little bit of structure, and a little bit of support. And we'll see how much they added on this design. Where is that slot? Is it going to be this one? And so if we edit this feature, we see the thickness is 1/8 of an inch. And remember, the 1/8 of an inch is 0.125. So we're going to extrude that shape. We really want it to go in that direction only, so it's completely supported below, like so. And then why not just make a mirror of that to make quick work of this? The feature we want to select is this one. The mirror plane needs to be something that bisects this, which is why we did a bidirectional extrude. It's just for symmetry purposes like this. You see that we made quick work of that right there. Now you can put some fillets in there to your taste. So it looks like it might fracture easiest right there. So I'm going to put some fillets in there to support. I can even do something like that. Just anywhere where there's a sharp edge, it's really going to be where stress is. That looks pretty good. We'll say we're good with that. Let's throw one more in there for good measure, like right up here. Okay, so now we need to put threads in there and we are done. Let's hit save. Take a good look at it right here. You might remember from our exercising class that the way we do the threads is, well, this is the outside of the nut, so we don't have to worry about that. We don't worry about that. It's just this one right here and the pitch. So let me remind you how to make threads. And we're serious about threads in this class. We don't like cosmetic threads. We like to have the real threads. And so to do that one, I think we're getting really good at it. We'll do these side half section views so we can see inside of it. And we're going to become experts here at cutting these threads right into this surface. Let's draw on that same surface. So new sketch. And you know what we do? We make a little triangle out there and then we do a spiral or a, what is it called? A coil. So we're going to make this sketch. We're ready to make the sketch here. And so we want it to be like a vertical line right here. And then here is where we do the cut. And you can make it look not symmetric, first of all, and then come in there, make sure these two are equal. That's how you make a thread. And then we also say that the distance between these two right here has to be 60 degrees for threads. The pitch is actually the distance between the teeth, or it's also the distance between right there. It's 1.5 millimeters. So we make sure you type in millimeters there. And for some reason, it just goes all over the place when I do that. I wonder if I can just grab it and move it over. Not sure why it wants to just jump way over there. I think it's just relative to the origin that it's doing that. Okay, so getting close here. What we can do now is, I guess, connect it with a construction line right there. And we want that to be a straight cut on the way in. So we'll make that vertical. And is that going to be this one? Okay, good. And normally what we do is just kind of out of habit when we're doing metric units anyway. This is parts, all of this is in inches except for the threads. And the threads we're making metric threads. We usually do 2 millimeters before we start cutting. Just, it's almost like you're getting the tool ready before you start cutting and doing that spiral. And then we begin our spiral. Oh yeah, but we do need a center to measure this on. So let's go back to our line tool and we need an axis about which we can rotate. We can't really use the x-axis because it's over here. So we're going to model this coil. It automatically selected the area. It's ready for me to select the axis. It's going ahead and putting 1.5 in there. It says it's going to go down 40 millimeters, which is more than enough. We could have gone probably 10 and gotten away with it. Now, the thing is, it went 10 inches, so that's not right. So we want to go 10 millimeters. Forgot that we're mixing units here, which is not always ideal. And you can see that's probably not going to be enough. So we'll just do 20 for good measure, and we've made it all the way through. And look at that, we have threads. And I think we're pretty much done. Of course, we don't want to do this. We want to remove this section view to show that the part is really complete. And we're good to go. All right, I hope that helps with designing a very simple clamp, and we can use this for testing the strength of the material. And we can also modify this design to see how much we can reduce the mass in order to still achieve a significant amount of load before it breaks. All right, I'll see you in the next video.